everyone. Myself Dr. Kadambari Agrawal from ABES Engineering College. So today I will discuss the relationships in UML, which plays a vital role in the diagrams, especially in the static diagrams. Outlines of today's discussion is relationship, dependency, association and multiplicity, aggregation, composition, generalization, inheritance and common mechanism. Relationship is basically is between the classes. A model is not complete unless the relationship between elements are described properly. Actually, in UML, the diagrams consist of static diagram, dynamic diagram, and architectural diagram. When we talk about static diagram, the main diagram is a class diagram. In class diagram, we identify the classes, and after identifying the different types of classes, we join the classes with the help of relationship. So the different kind of relationship and their identification is very important. The relationship gives a proper meaning to a UML model. There are various kind of relationship. The first relationship is dependency. The second one is association. Third one is aggregation, the fourth one is composition, and fifth one is generalization. And we implement generalization with the help of inheritance in programming language. Dependency is basically a very weaker kind of association, and little bit stronger than dependency is association, then aggregation, and inheritance is the strongest form of relationship. In this diagram, you can see the various representations of the relationship. Dependency relationship is represented with the help of dotted line with headed arrow. Association relationship is a straight line. Aggregation relationship is a line headed with a diamond box. Composition is a line headed with a diamond filled box. And inheritance is a line with triangle. Relationship, the first one is a dependency. A dependency between two classes declares that a class need to be know about another class to use object of that class. In this particular kind of relationship, one is an independent class and one is a dependent class. The arrow head is towards the independent class. In this particular example, the user interface is dependent on the blog entry class because it will need to read the contents of a blog's entry to display them to the user. You can see here. Dependency is used to represent the dependency between two elements of a system. Dependency is represented by a dotted arrow as shown in the following figure. The arrowhead represents the independent element, as I've already told you, and the other end represents the dependent element. This is the weakest relationship between the classes. Association. Association is very common relationship between the classes. Actually, in UML, if we identify the different classes, then the most common joining between two classes is through association relationship. Association is used to represent the relationship between two elements of a system. The two ends represents two associated elements as shown in the following figure. You can see person is one of the class and company is the second class. So there is an association relationship between person and company. The person works for company and company has many persons. So here we are representing the multiplicity symbol also. A person can work for many companies or it may work for 0 or 1 company. A company can have many employees. So these are the multiplicity symbol that I'll be discussing you. Association, when we talk about association, there comes a term multiplicity. We can define multiplicity in a manner that how many instances of one class is associated with single instance of other class. There are three common kinds of multiplicity across an association. The one-to-one, one-to-many, and many-to-many. Just see this example. The person is one of the class, its second class is company. So here the multiplicity is person can work for many company. So if I write on the line works for, then star will come. It will show many. A company can have one to many employee. So if I read the association that way, company has many person, then it has one to many multiplicity. So it will be represented with one dot dot star. These are the example of multiplicity with their notations. Suppose I am having a class department, another class is boss. A department has one and only one boss. So I will write here one. So this is an exactly one multiplicity. Second example is we have an employee class and we have a child class. An employee has 0 to many children. So I will write 0 dot dot star over here. It is 0 or more kind of multiplicity. Suppose we have a class boss and second class is employee. A boss is responsible for one or more employees. So it is one or more. So one or more will be represented with one dot dot star. 0 or 1. Suppose I am having an employee class and spouse class. An employee can be married to a 0 or 1 spouse. So it will be represented with 0 dot dot 1. Specified range can also be mentioned in multiplicity during association. Suppose I am having an employee class and vacation class. Then an employee can take from 2 to 4 vacation each year. Then it will be represented with 2 dot dot 4. Multiple disjoint ranges can also be represented with the help of multiplicity. For example, I am having an employee class and committee class. An employee is a member of 1, 2, 3 or 5 committees. Then it will be represented by 1 dot dot 3 comma 5. Then the third kind of relationship is aggregation. Aggregation is basically a stronger form of association. It is basically a whole part or part of association. It represents the stronger relationship between the classes. An aggregation parent and child entity maintains has a relationship. Any modification in the parent entity will not impact the child entity or vice versa. In UML diagram, aggregation is denoted by an empty diamond which shows their obvious difference in terms of strength of the relationship. For example, if I'm having a company class and second class is department, then the relationship between these two classes is a stronger form of association. So I will represent it with the help of aggregation. Although association also exists between these two classes, but deep study will invoke it in a form of aggregation. The next form of relationship is composition. In composition, the parent owns the child entity, so that child entity cannot exist without the parent entity. We cannot directly or indirectly access the child entity. In UML diagram, the composition is denoted by a filled diamond. As you can see from this diagram, we are having two classes. The one class is department, second class is staff. So here we can say that staff is a part of department. So for example, hospital has one or more department and each department belongs to exactly one hospital. If hospital is closed, so all of its department will also close. So this is basically a very stronger relationship, even stronger than the aggregation. The next relationship is generalization. Generalization is basically a parent-child kind of relationship. In this relationship, a general thing and a more specific thing of the same kind are related. The child inherits the attributes and operation of the parent class. Operation can be redefined in the child and override the operation of the parent. It is drawn as a directed line with an open arrowhead. It is basically is a relationship. These are the some form of generalization: hierarchy, genericity, polymorphism, and patterns. In hierarchy, the cumulators are organized into a tree-structured form. At the root of any subtree are found all the attributes and behavior common to all of the descendant of the root. Genericity, the cumulators are expressed with the aid of a parameters. Various specializations are distinguished by what they are provide for the parameters. Polymorphism captures cumulators in algorithms. Polymorphism allows the nested logic. Patterns expresses a journal solution to the commonly occurring design problem. Inheritance. This is a fifth kind of relationship, very strong form of relationship. Inheritance is an implementation mechanism for the generalization, specialization, and relationship. This is basically a programming approach to implement generalization and specialization. Inheritance can be single, multiple, multipath, multi-level, hierarchical, and hybrid. So these are the difference between association, aggregation, composition, and inheritance. Just see this example. If owner feed pets, then pets will please owner. This is the association between the pet and the owner. Second example is a tail is a part of dog and cat. This is basically an example. If it is a part of relationship or whole part of relationship, then it is aggregation and composition. A cat is a kind of pet. It is a relationship. It is basically a generalization, and generalization is implemented with the help of inheritance in programming. These are some real examples of relationship. You can see association, normal association between the passenger class and airplane class. Directed association is also there. If I write arrow, reflective if the class is associated with itself. Multiplicity symbols are also represented on association. Aggregation is between the library and books because books are the part of library. Composition is also existing between library and books because books are the part of library class. Inheritance, fixed account and bank account. Bank account is inheriting the features of the fixed account plus its own features. Similarly, realization, printer setup and print. These are the quick revision you can see from this diagram. This line with a triangle shows you generalization, dotted line with triangle realization, aggregation. You can see here this line with a diamond, empty diamond, composition, line with a filled diamond. Dependency is the weakest relationship with the line and arrowhead, and association can be single line or it can be directed headed arrow. This is a brief difference between generalization and aggregation. Aggregation is basically has a relationship, generalization is a relationship. It is general aggregation is represented with the help of diamond symbol, generalization is represented with the help of triangle symbol. Generalization is stronger than aggregation. These are some common mechanism which is used in UML, the specification, adornments, common division, and extensibility mechanism. Adornments. Each element in the UML has a unique graphical notation. Besides these, there are a notation to represent the important aspect of the element like name, scope, visibility, etc. And we have already discussed one of the adornment, that is a multiplicity. Common mechanism. Common division. Object-oriented system can be divided in many ways. The two common ways of division are division of classes and object and division of interface and implementation. Common mechanisms and extensibility mechanism. Basically, UML is an open-ended language. It is possible to extend the capabilities of UML in controlled manner to suit the requirement of a current system. So, the extensibility mechanism that we used in UML are stereotypes, tagged values, and constraints. These are some references. Disclaimer. Thank you so much. If you liked my discussion, please like and subscribe the channel.